Hello again, welcome to the MasterCAM course. In that lecture, we're going to talk about 3-axis toolpath. As you can see here, that kind of product is created by using the actually SolidWorks. After that, I'm going to save that file. And then after that, we can easily open that file by using the MasterCAM. So when we use the open options, file open options, we need to change the types. All types can be selected, and then we're gonna see that SolidWorks file like this, and then we just need to double click on it. Okay, let me delete that part as well. Yeah, I just need to double click on it, and then it's gonna open like this, and then we can use the isometric perspective. After that, of course, we need to turn to actually C plane. My C plane can be right. You're gonna see that Z axis is here right now, and then transform and select my model and transform and rotate options. So I just need to write my degree here. Oops, sorry. We can select my file and transform and rotate options. And then, and as a method, we can prefer to use the move options. Okay, so after that, we can turn to C plane as a top view again. So that's okay. After that, let me turn to the top view here. Okay. So after that, it will be better for us to actually create some and circle here. How can we create my circle? So I need to turn to 2D, and then I just need to hit the Z, and then I can select this curve. Okay, this is my Z position. And after that, we can turn to the wireframe and curve on the H options, and then we just need to select that curve. So when we select that H, my curve is projected automatically. And after that, I can turn to the transform and move the origin, and then I just need to select the midpoint of that circle. Oops, sorry. Of course, before that, we need to turn back to 3D. And then we're gonna hit the move to origin, and then we just need to select the center of the circle. Yeah, that's it. After that, we can easily turn to right mouse button and clear color options, and then we can delete that boundary. Okay, and we are ready right now. We can easily create our toolpath. Let me save my file. It can be example 2. Yes, it's fine. Okay, anyway, let's focus on our toolpath. When we focus on our toolpath, actually we can create our, and first of all, we can create our, and the 2D toolpath. I mean that face toolpath. Okay, let me turn to 2D and Z position 0. And then curve on the H options, and then I can select my curve. So after that, let me save my file, and then I can turn to the machine and the default machine. And then that's it. We can easily turn back to here, and this machine is selected. And then let me turn to here, use the right mouse button, mill toolpath, and then I'm gonna use actually face toolpath. So we just need to select our chain. This is gonna be my chain, and hit the OK button. And then I can turn to the tool, use the right mouse button, and then we can easily select my tool. My tool can be 20 millimeter diameter, and this is going to be my feed rate, and this is going to be my cutting speed. It can be like this, and my spindle speed and the feed rate calculated. According to, actually, we can also use the edit tool, and we're gonna see that number of the flutes here. This is the 4 flutes we have in our tool. Okay, let me turn to actually linking parameters. That can be 5 millimeter as a absolute, 3 millimeter, and 1 millimeter as a absolute. And as a absolute position, we can use as a depth 0. After that, we can turn to the cut parameters. In the cut parameters, we can prefer to use dynamic toolpath. And this is the approach distance. This is the actually calculated from and my tool diameter. According to my tool diameter, 50% of my tool diameter, this is 20, and then we're gonna get 10 millimeter. And then this is the step over. You're gonna prefer to use the 50% of my and the tool diameter, so it's gonna turn to actually 10 millimeter, and this is the actually degree. Okay, so this is the stock to leave on the floor. It can be 0, and then we just need to hit the OK button, and then we're gonna see that's kind of dynamic toolpath. This is the best toolpath actually for actually circular stock. Okay, so if you intend to create that kind of toolpath, for example, and we can start from 10, 5, and 3 to 0. And 3 to 0, it means that we need to cut 3 millimeter. So to be able to handle that, we can turn to depth cut and activate it, and then we can write 1 row maximum step row, and then we can also activate 1 finish step, and this is the number of cuts, and 0.1 millimeter as a final depth. And then we can calculate our toolpath, and then we're gonna see 4 toolpath here, and one of them is finished. 1, 2, 3, and this is the last one. Okay, that's also possible to create that kind of toolpath. So if you intend to use actually and bigger than this circle, so that's also possible. So we can turn to top view, we can turn to the wireframe and circle center point, and then we can create new stock. For example, it can be 300, and then I can hit the geometry button, and then we can use the right mouse button and delete this one and add new one. So when we add new one, actually we can also use the reverse direction options here, but it's not important. And then we're gonna calculate our toolpath according to that stock. So okay, let me create a contour toolpath. Let me turn to here and contour toolpath. Of course, at that point we need to select this one. We're gonna start from here, and then I'm gonna create 10 millimeter tool. This is my feed rate, and this is my cutting speed. And then when I am turned to linking parameters, it can be retract absolute 5 millimeter, feed plane absolute 1 millimeter, and top of stock 0, and depth can also be selected like this. According to this perspective, actually we can easily prefer to, as a contour type, we can easily use the ramp options, and then we can organize our depth. Our depth can be 5 millimeter. This is the and one actually rev for 5 millimeter. We can also reactivate linearization. Otherwise, we're gonna see the G1 code in our G code. Okay, I don't want that. I'm gonna see circular interpolation, so that's why I'm gonna recancel it. Okay, and what else? This is actually compensation type calculated by the computer, and we're gonna on the left side according to my cutting direction. And then let me activate my toolpath. And then we're gonna get that kind of toolpath. You know that this is the 5mm distance. At that point, actually, that part is also quite important. If you would like to get and some distance here, let me turn back to here. So actually we can easily take this one. This is the make pass at the final dab. As a final dab, we're gonna see the full circle without any Z movement actually. So you can see that this is the final depth options. Okay. Okay, this is the actually 2D perspective. Okay. After that, maybe we should also create some actually drilling process. So I can select this one and this one. Okay. Yeah. And we can use the right mouse button and mill toolpath. And actually we can select drilling process. We can select this one and this one. And then we can hit the OK button. Let me turn to the tool and create tool. And it can be center drilling process like this one. And linking parameters, it can be absolute retract 3 and retract top of stock 0 and absolute depth can be -3. And then we can hit the OK button. So this is actually my drilling process. After that, we can turn to home, analyze, and analyze entities. This is 8.5mm. And then we can create drilling toolpath and we can select this one and this one. And we can create our new drilling tool. It can be 8.5mm. This is my feed rate and this can be my spindle speed. When we turn to the linking parameters, this is the retract, top of stock 0, and when we turn to depth, you can see that according to this perspective, actually, we can easily select this depth. Okay, so it can be minus 40. Okay, after and under this part, maybe we should also use actually some different perspective. We can also turn to the cut parameters. In the cut parameters, we're gonna prefer to use pack drilling and with 10mm. And then we can hit the OK button. Okay, that's it. This is the 2D toolpath. After that, we're gonna focus on the 3-axis machining process.